through this question. So the question is how many, what is it, 2018 question 4? How many, what's the last, what is last non-zero digit of 50 factorial? No? Okay, and I don't really like this question, okay, especially in this context, because, well, there's sort of a standard, so where it's coming from, I guess, is sort of a standard, I would like to call it a standard question, because it comes up a lot. It's like, how many zeros at the end of, like, let's say 50 factorial, yeah? And so the problem with this kind of question in a competition is it gives, I think, a very unfair advantage to people who've seen this question, because sort of you can kind of avoid a lot of the traps in here, especially when all that matters is the answer. So let's just look at this question, how many zeros? If you know that, then say for the last non-zero digit, you would try to get rid of all the zeros and then find the last non-zero digit, right? So for something like this, okay, 50 factorial is 50 times 49 times 48, all the way down to 1, right? And to make a 0, it's just basically a factor of 10, right? And 10 is 2 times 5, and since there's lots of 2's in all the even numbers, and we'll talk about it, so then it becomes a matter of knowing how many 5's there are. Okay? But the first thing that you'll be tricked on if you try this problem the first time is you'll just count the multiples of 5, right? And if you just count the multiples of 5, you'll miss out on sort of 5 squared like in 25, and you'll miss out on 5 squared in 50, yeah? So
you get 12.
Yeah, so I guess what I'm trying to say is you'll get 2 5's from 50, you get 2 5's from 25, and you get 1 5 from all the other multiples of 5. So that's 12, right? Okay. So the answer is, I guess, 12. And so if you know that, okay, then to do this question, you might just want to get rid of those 12 zeros by dividing by 10 to the power of 12, right? So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Yeah, we'll just so to get rid of you can get rid of okay. I'm not going to be lazy, but I've got to line it up right. Maybe I want it to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then 11, 12, 13, 15, 16, 17, 19, 20, 50, 41, 42, 43, 44, 46, 47, 48, 49. Okay, so if you want to get rid of all the 5's, right? So here you have, we can just get rid of, so we need to get rid of 12 zeros, right? So we can get rid of maybe 5 of them.
2 5's? Yeah. Wait, 2, 5, 25, 4.
So if we get rid of these zeros, that's 5 of them, yeah?
We give them 5 and 2.
Wait, what?
So here got rid of the 2 and the 5 at the same time, right?
Oh, so you got rid of 10, 20, 30, 40, 50.
Yeah.
Zeros.
So now these are just 1, 2, up to 5, yeah?
You made another 5.
And then you get rid of these 5's, right? So if you get rid of these 5's, you get
another 2, 3.
so you get 1, 2, 3, 4, 5, right? Sorry, not 1, 3. Yeah, sorry. 1, 3, 5, 7, 9. Okay. So that's 5 5s, right? And then these are the last 2 5s. So that's all the 5s. And then so we need another 7 2s to get rid of, yeah? That's gone. I can just write these out. 3, 4. And this is gone. And then we need to get rid of 7 2s. And then we're done. So for example, you can get rid of the 8. Here,
Let's
that's
get 2
3.
to the power of 8, so that would be 3, and then 2 to the power of 4, so that's 16, right? Can't you just get rid of 8 and 16 and make that 1 and 1?
Yeah, so here's 4, right? And here's 3. Yeah, you can get rid of 7 that way. But you can sort of really do it however you like, right? Okay, so then now we got rid of the zeros to find the last non-zero digit. So this is where sort of this idea of, well, we don't really need, it's not modular arithmetic, but you're just kind of comfortable with the idea of just looking at the last digit, yeah? If you're only looking at the last digit of the product, it's the same as taking the product of the last digits and then taking the last digit. And you can take the last digit at any moment in the calculation and it'll still work. Okay, so
Wait,
all
so
these,
we're getting rid of the 10, 50, you got
so all these just become
2
sevens
5s
now,
and 1 0.
yeah? And then all these just become 8s,
2 5 and 1.
and these all just become 9s.
Yeah, that's it.
Okay, and this just becomes a 6. There's a 9. This is a 4 now. This is a 3. So all these are just 4s. These are 3s. So it saves a bit of writing now. See, there's a 2, 2,
Wait, what?
and then these are all 1s, right?
What are we doing?
Getting rid of this.
So we're getting rid of the tens digit of all the numbers.
Oh, okay, so now we have no 10s.
Tens digits. Okay, and then obviously we can ignore the 1s because they don't change anything. Okay. And that was a nice observation to know that it has to be an even number, right? Because there's lots of 2s.
It does not make 2 the answer as this the most common on 1 and 2.
Wait, did I put
So
this?
then
Were there meant to be
it's
6s here?
answer to-
Did I forget to write the 6s?
Yeah, but then
No, I erased the 16 here, but I didn't erase. I didn't erase the other 6.
2 times
right?
2 times 3. There's more 2s than 3s for the answers. The answers still. 2 times 2 times 2 times 2.
Yeah, so the 16 disappeared
2s
here,
and 3s for the answers.
the 8 disappeared here, and the 5 disappeared here, and the 5 disappeared here. But everything else is still there. We got rid of the 1s, yeah? So then I guess it's just a matter of multiplying these nicely. You know, for example, if 2 9s go to make an 81, right? Then that's just a 1, yeah? So then we don't have to worry about 4 lots of 9. They won't change the answer. Yeah.
6 times 6 times 6. It's always
So doesn't the 8 become
Yeah.
a 1? Oh, but it's okay. Like, we don't need it.
Yeah, I mean, for the same reasoning, 2 3s will make a 9. So 4 3s will make 2 9s,
The
which will
1
be a
doesn't
1.
matter, so it's just...
Yeah, so 1 won't change.
You can cancel all the 61.
Yeah, you can. So what's the 6s?
Because 6 times 6 is 36.
6 times 6 is 36. Yeah, so it's the same as just having 1
Yeah.
6, right? Yeah. It's the same as just having 1 6. And so anytime you have a 6, it just collapses into the same 6. Yeah. So for example, 2 times 3, you can delete as well.
So you can just delete all the 6s except for the first one.
And here you have a 2 times 3. And you have a 1, you can get
Wait,
rid of.
why did you delete all the 3s?
Oh, because 3 times 3 is 9. 9 times 9 is 81.
There's
Ends in a
another
1.
freedom too. So there's only 1.
Yeah.
You can cancel the 3s.
4 7s are 1 as well.
Yeah, so 7 times 7 is 9. Ends in 9. And so 4 lots of 7s will end in a 1 as well.
I think you raised the 8.
Did I erase the 8? Okay, and then
4s.
yeah. So what about 4s? 4s times 4 is 6.
Wait,
Right.
As well as 4.
16. So it ends in 6. So I can erase an even number of 4s because they all collapse with that 6 to end in 6. Yeah.
we just erased all the 4s as well,
Not all of them. We have one. Here.
except for the first one. Yeah.
This
Okay, and then
Oh,
2
there's
times 3 is a 6.
There's 2 4s.
That's 2 4s. So we can get rid of them both, yeah? Because 2 4s is 16, and then 6 times 6 will end in 6.
yeah.
Is that a 1? Yeah. Okay, number 1.
It's a 9 and 9. It's a 9 and 9. So
Is it 7 and 9 under the 6 or under the 5? Yeah, it's
you
6.
can erase the 9.
The 9.
There's 2 9s.
Okay, yeah, there's 2 9s. Good. And then this is 64.
It's
Ends in a
4,
4, and a
6.
4 would be a 6. So that 6 will collapse with that 6.
So no, you just do it.
Yeah, at some point you can just do it. Yeah, but like, yeah. You know, this will end in a 9.
Yeah, it's 8 and 7.
And then there'll be 2 of
17.
these. It'll be a 6. So it'll be 6 times 2. Yeah. So there's 49, the 9 is 3 times 3. Combined with these two gets 2 6s. That'll collapse with that. And so it'll be 6 times 2, which is 12, right? So the final thing should be 2. Yeah. Yeah.
Or you will end with this.
Yeah, so considering the last digit thing is sort of like the idea of modular arithmetic. And you can kind of just do it in problem solving, but it's nice to have like the theory behind it. And we do it in kind of a nice way anyway.